Welcome to homework.
Okay, folks, so in this problem we have an electron that has an instantaneous velocity of v equals something times I hat plus something times j hat, and this electron with this velocity is moving through a uniform magnetic field B, which is given by something times I hat minus something times j hat. So the first thing we're going to do is we're going to find the force on the electron due to the magnetic field. And then after that, we're going to do the same thing, but with a proton instead of a electron. Okay, so the first thing to realize in order to do this problem is that we need to use the following equation. We need to use F equals Q V cross B. Now in this formula, this Q is the charge of the particle that you're interested in. So for the first part, part A, we're interested in an electron which has a charge of approximately 1.602 times 10 to the power of negative 19 coulombs. So, well, actually, there's a minus sign there because electrons are negative. But if it was a proton, which is part B, we would have positive 1.602 times 10 to the negative 19 coulombs. But anyway, that's the charge, Q, and the V is the velocity of the particle that you're interested in. So for the electron, in this problem, the velocity is given by this vector, and the B is, of course, the magnetic field, the value of which is also given in this problem. So okay, so now let's do part A. So for part A, let's just do some plug and chug and calculate the answer. So the force on the electron. By the way, this formula right here is called the Lorentz force. So whenever you have a particle that is moving, a charged particle that is moving in a magnetic field, it experiences a force due to that magnetic field, and that force, we call it the Lorentz force. So because this is a vector equation, it's going to involve a cross product. So let's say that this is negative 1.602 times 10 to the negative 19 coulombs multiplied by V, which is Vx I hat plus Vy j hat. So this thing cross product with the B field, which is Bx I hat minus By j hat. So this is a cross product, and the result of this cross product is, of course, a vector, and that has a magnitude and also a direction. So if you remember how to do cross products, I'm not going to bother doing the cross product in this video because we don't have enough time. But if you do the cross product, you will find that the answer is going to be this. It's going to be 6.24 times 10 to the negative 14 newtons in the k hat direction, which is just the z direction. So this is part A. And part B, we basically do the same thing, but with the Q, instead of Q being a negative number, which is negative 1.602, we're going to plug in Q equals positive 1.602 times 10 to the minus 19 coulombs, and then the whole thing copied down here. And after you have done your cross product, you will find that the force is going to be exactly opposite of the answer that we got for part A, which is negative 6.24 times 10 to the power of negative 14 newtons. in the k-hat direction. Okay, folks, so this is the answer for this question. Let me know in the comments if there's anything that you didn't understand. See you in the next video.